Hi, I am Samigda and I will be solving question number 2 of homework 11. Okay, so what do we been given for question number 2? We have been given three functions of v, where the first function is f v equals to exponential of minus mod v. Second is sine square v by v square, and third is 1 if mod v is less than equals to alpha, 0 if mod v is greater than alpha. Now what it may represent, fv may represent an autocorrelation function of WSS by setting v equals to tau, or spectral density function by setting v equals to omega, or both. Now what do we need to find? We need to find is that does Fv represent an autocorrelation function of WSS or spectral density function of WSS or both. So now we go to the solution. So now Fv equals to exponential of minus mod V can be used to represent both the autocorrelation function and the spectral density function of a WSS process. How? Autocorrelation function of a WSS process is given by Rx t1 comma t2 is expectation of x t1 x t2, which can also be written Rx tau, where xt is a WSS process, and the spectral density function of a WSS process is given by xxx omega minus n, which is equals to minus infinity to infinity Rxx t1 t2 or Rxx tau e to the power minus j omega t1 minus t2, which is e to the minus j omega tau d tau. Okay, now in order to prove that whether it represent or not, we need to satisfy the following properties. We can see that fv is equal to exponential of minus mod v is an even function, right? The autocorrelation function and spectral density function of a WSS with fv equals to is also an even function. Second part is fv equals to e to the power minus mod v is greater than, which is non-negative. So autocorrelation function and spectral density function will also be non-negative. Now fv is also a real valued function, so the spectral density function will also be real valued, and fv is also positive definite, and autocorrelation function and spectral density function is also positive definite. So therefore we can say that from the above properties which fv seems to satisfy, so we can say that fv equals to e to the power minus mod v can represent autocorrelation function of a WSS process by replacing v equals to tau, and also represents spectral density function by replacing v equals to omega. Okay, so now we come back to the second part. Second part, we have been given sine square b by v square. It can also represent an autocorrelation function and spectral density function of a WSS process. Now from the properties from part 1, what are those properties? The properties are that fv should be an even function, should be non-negative, should be real value, should be positive definite. But does sine square b by v square satisfy them? Yes. Fv is even and non-negative. We can say it's a square function, so it will be even and non-negative. It's also a real valued function, because the only point of contention which we can see is at 0. But if we take the limit of fv at v approaching 0, it will be 1, and so it's also positive definite. So fv equals to sine square b by v square can represent autocorrelation function of a WSS process by replacing v equals to tau, and also represent spectral density by replacing v equals to omega. Okay, and also it is continuous function, so it is. So now for the third part, fv cannot represent autocorrelation or spectral density function. Fv is not continuous, it is not continuous. So it simply is that it also it depends on where alpha is. Okay, so so we can say that fv equals to 1 if mod of alpha is greater than is less than equals to alpha, and 0 for mod of v is greater than alpha, does not represent autocorrelation function nor spectral density function. Thank you.